Good morning, good afternoon, and good evening for all those that are attending the Phase 1 Industrial Cameras for Environmental Monitoring webinar. Thank you so much for taking the time to listen in and view what we have to share today. This is one of multiples webinars that have been shown throughout this year. This is going to take on more of a case study application or application-based more than a technical-based presentation as the previous ones have been. Let's start by introducing myself. My name is Dana Brown. I'm the Americas Sales Manager for the North America and South America. Our office is in Broomfield, Colorado at the Rocky Mountain Airport. I have a sales team that's dedicated for integrators, drone dealers, and our Phase 1 systems. So at the end of this presentation, if you have some questions, please reach out to my contact information that you'll see at the end, and I will get you to the right expert in your area to be able to discuss in more detail how Phase 1 cameras can exceed your expectations with your solution. We are taking questions throughout this webinar. I have Ryan Boswell that'll be monitoring that. And at the end, we will present some of those questions and answers. So let's go ahead and start with the overview of Phase 1. Now, many of you have probably, if you've been on the previous ones, this is very familiar to you. For others, this may be the first time. So this here is an image of our headquarters in the US at the Rocky Mountain Airport. But Phase 1's a world-leading imaging, medium format digital imaging provider. When you think of medium format cameras, Phase 1 typically comes up. We are focused though from the camera side, the imaging side, and then building applications around that. We are a trusted brand. We have worldwide distribution, 24/7 customer support. And I think if you ask any of our current customers, we are very customer centric, and we build innovation based on those customers' needs. This is one of my favorite slides, and the reason for that is it shows really the global coverage from a Phase 1 perspective, from our R&D center in Japan with amazing lens and shutter technology, to Israel, which really focuses on the industrial side of our camera solutions and IX capture software, to Copenhagen, where our world headquarters is located on the imaging side. So nice coverage of the globe with sales and support in almost every continent to help support you and your customers. Let's talk briefly about the technical edge that Phase 1 has from our perspective from having metric accurate cameras. We are not a company that has one camera or one size that fits all. We build technology that's focused on market and application needs. So from fully integrated aerial systems, for those organizations that don't have the integration bandwidth to build their own, they can buy them off the shelf from us. And then there are some customers or integrators that have customers that they want to take our camera and integrate it with other sensors for a complete customized solution. We have cameras for that. And lastly, but not least, we have the cameras for the UAV applications, which are designed lighter with different features than you would get from the 150 megapixel, the 190. From our operational edge perspective, our cameras are all qualified for metric accuracy. I'll cover that in a minute. We have an amazing, innovative central shutter technology, which again, we'll cover that in the next slide. The other nice thing about this is our minimum of 7-year service and support. You know, we released the first camera in the industrial over 6 years ago. Some of those cameras are still in use. It just shows the robustness and the industrial component of our cameras. And then we also have a premium warranty program, which I will cover over the next couple of slides. Now for this presentation, the case studies, these are all done prior to our release of the 150 megapixel, which we just announced this month. So the specs of the camera that we're going to discuss is the 100 megapixel, the IXU RS series that has 11,000 pixel cross track. The shutter lifetime is 500,000 cycles at 0.6 seconds per frame, and of course a range of lenses. And then we'll talk about the shutter technology on the next frame. I mean, there's a lot of engineering that went into this. We're very pleased with the results that since we've announced this in 2016, that have far exceeded the 500,000 cycles, but that's not as important as just having something that's reliable in the field, where it relieves that anxiety of having an inferior product. So this is a superior product that you don't have to have that concern. The nice thing about what's new with our IXMRS 150, which you see at the very bottom, our IXMRS series now is a half a second per frame, or 2 frames per second, which is an improvement even from 2 years ago. That's the nice thing from the innovation standpoint, as the continual, just this year alone, we've released 4 new cameras. So certainly building cameras specific for customer and market needs is one of our strengths. Now, the premium warranty is an awesome package because, again, it's that insurance policy so that you have minimum downtime, if any at all, should you have a problem with the system and or the shutter. We have a unit that's available to ship to you if you're under the premium warranty program to minimize your downtime while your system or shutter is being repaired. Technically, by continuation of the premium warranty program, if you stay on an annual basis, you really have unlimited shutter activations. So it's a nice insurance policy and peace of mind to have. All of our cameras, this is the unique part about phase 1, all of our cameras, our lenses have distortion models for each one, and it stays within that lens itself. So it virtually means that you have a distortion-free image from that lens and camera. Now, when it comes to our range of products, just keep in mind then our core is on the imaging side. So it's really the first 2 columns is the core of our technology, whether it's the lenses, the shutters, or the back, the camera itself. We have a range of 50 megapixel to 190 megapixel, RGB, NIR, combination of both, different types of storage capabilities and communication protocols. And then we have the ability with the third column, the IX controller, the onboard computer, then that can synchronize up to 6 cameras, which has been a trend lately for our companies, customers wanting oblique systems that have up to 6 cameras. And last but not least, the important, I call it the glue that holds the hardware together, is the software components, the IX Capture, the Capture One, and our SDK for developers that really make our cameras sing. Okay, so now we are going to talk about why you probably logged into this webinar, is to cover some of the aspects of how these cameras are being used. And of course, there's many environmental applications. Sometimes it's hard to handpick a few of them, but this is what we're going to cover today. They're all different configurations. Some are just on their own single camera systems. Others are multiple cameras or multiple sensors. And so you get to see how some of these different configurations and the benefits from those configurations. We're going to start with NASA. So NASA has a program called the G-Lite program. And in this program, they've integrated, they have the internal resources to integrate sensors on their own, different types of sensors to create then answers for what they're capturing on the ground. I just moved to the next slide. A lot of these are a little bit synonymous and overlap, but you will see some differences. First and foremost, from a phase 1 perspective of the G-Lite program is the camera. It's a phase 1 100 megapixel camera with a 50mm lens. But in addition to that, it has other sensors, LiDARs, vernier imaging spectrometer, and other types of sensors then integrated. Now, why do they have all these sensors? Well, it's to answer questions about the function of terrestrial ecosystems. The LiDAR provides the spatial distribution of the canopy part when you're looking into a forest, the 3D this section of it. Then you have other types of sensors like the next one to look at photosynthetic pigments of the species. You have thermal measurements. And again, important for me from a phase 1 perspective, that high resolution imagery at just over an inch resolution for them to identify canopy features and species. And then you also have the photosynthetic activity measurements from the SIF. So why did NASA choose a phase 1 camera? Really, it's the resolution, 100 megapixel imagery, getting that 1-inch GSD on the ground, having a wide swath or 11,608 pixel cross-track coverage. And what's common that you'll see, it's very unique, frankly, to the phase 1 product line, is the dynamic range and the ISO range, being able to be very effective in low lighting conditions. Now, I don't want to bore you with reading this, but I mean, this kind of gives an overview of why NASA has this product. So I'm just going to read this relatively quickly. The result of this instrument fusion effort was G-Lite, a unique system that permits simultaneous measurements of vegetation structure, foliar spectra, and surface temperatures. The complementary nature LiDAR, optical, and thermal data provide an analytical framework for the development of new algorithms for mapping plant species, composition, plant functional types, biodiversity, biomass and carbon stocks, and plant growth. This will enhance our ability to design new missions and to produce data products related to biodiversity and climate change. G-Lite is designed to give scientists access to the data that is needed to understand the relationship between ecosystem form and function and stimulate the advancement of synergistic algorithms. What exactly does that mean? Well, essentially, identifying areas that have been devastated maybe by a natural disaster and monitoring regrowth of those areas would be one. These here are two images, which I'll show you where I found these later. They're available to the public on the NASA website, of pre-hurricane in Puerto Rico in 2017 and then post-hurricane. This is the same area. I don't know if it comes over well in the webinar or not, but there's certainly less foliage and trees in the picture on the right compared to the left. So when a natural disaster occurs, what are the effects of the forest regrowth? Will the indigenous species regrow? How long will it take? Will invasive species overtake the area? How does that affect other vegetation and animal habitat? Is human intervention needed? So these are the types of questions that this program answers. Now, I can't say Spathodea campanulata, so I'm not going to say that. I'll just refer to this as the African tulip tree. So it looks like a pretty tree, but it's not so pretty in certain areas where it's not intended for. This is the tree that NASA is monitoring specifically in Puerto Rico and other parts of the US. The problem with this tree is its rapid regrowth, and it's associated with abandoned agricultural land. Now, from the Center for Agriculture and Biosciences International, this is the impact that this African tulip tree can have on its where it grows. It monopolizes resource, it's competition for shading for other species, and it's rapid growing. How does that impact that area? Well, it alters the habitat, ecosystem change. It negatively impacts agriculture, and it's a threat to the loss of native species. So this is a critical thing to have to identify. How do you identify something like this? Well, that's where the G-Lite program comes into play, because it has multiple sensors based on canopy height identification, but most importantly, with the phase 1 camera, analysts can identify the species, map the growth, and decisions can be made for human intervention. You can see on the far right kind of a highlighted picture of those tulip flowers, and then the decision tree process to help identify that, to correctly and accurately identify those trees and monitor the growth. So how does the phase one make this possible? What are the features in the camera? Well, we kind of talked about that earlier. It's the high resolution with the 1-inch GSD and the cross-track coverage of 11,000 pixels with the wide dynamic range. That's what gives the ability then to help identify these trees and monitor the growth and intervene if necessary. What I have up here is for you to, at your leisure, to review. This is the NASA website, and where they have the island of Puerto Rico, and you'll see there's multiple color bands on the island. Each one of these color bands represent a time where the phase one camera captured imagery in that particular area. And as you can see on the legend on the left, you have different times of the year and over 2-year period, pre-hurricane and post-hurricane, that you can do. You can see the analysis and the differences or the devastation that occurred. And there's some additional reading material if you'd like on the NASA G-Lite website. I've given that to you there. And if any of this you don't capture right away, no worries, I can forward it to you later in an email. But this is the comprehensive part of G-Lite where it gives you all those details and supporting articles. Let's go to the next one. All right, so we covered the tulip tree. Now we're going to talk about a different configuration in Alaska. So again, the tulip tree with NASA, single camera, multiple other sensors. Moving now to caribou monitoring, there's no other sensors from a data collection standpoint other than the imaging sensors themselves, which is 3 100 megapixel cameras. All right, so in the 1970s, people were concerned about the effect of the Trans-Alaska oil pipeline, expanding oil development and increased disturbance from use of aircraft and snowmobiles on caribou. Although there was some displacement of caribou calving in the Prudhoe Bay oil field, in general, caribou have not been adversely affected by human activities in Alaska. Pipelines and most other developments are built to allow for caribou movements, and caribou have shown they can adapt to the presence of people and machines. As human activities expand in Alaska, the great challenge for caribou management is for man to consider the needs of caribou herds and ensure they remain a visible, healthy part of Alaska's landscape. Now, caribou is essential to be managed because of the need for local residents that live off the land. And so surveying or counting them is important for that species. That way the organization then can determine the harvesting numbers for that particular species of caribou. But decline in calf populations then can be identified because it comes down to how many babies are there to know the growth of the herd or the decline of the herd, and those can be remedied. There you'll see an image of the caribou there on the left. So now it comes down to, how do you count caribou? Well, prior to the phase one system, it was a black and white film camera was used to count the caribou herds. The old systems, which featured a Zeiss RMK, a large format film camera, they functioned poorly in low light conditions, covered limited ground swaths, and cost precious time by requiring pilots to periodically land and reload film. So you can see here there's a factor for change. What is that factor of change? Well, the camera didn't work well in low light conditions. It had a narrow swath coverage, and they couldn't even complete a herd collection in some cases because they had to reload film. So this was a driver for that. Now that's just on the capturing side. What about on the counting side? In the past, staff had to manually lay out all of these 9 by 9 inch printed photographs, overlap them, try to determine which parts were counted, and of course you can probably imagine that the accuracy counts were sometimes put into question. What were the factors for change for the counting side? It's too time consuming. It takes too much time to put these photographs together. The image quality itself was many times poor. I couldn't even see how many caribou I needed to count on that particular image. So certainly there was drives for change there. So what fixed that problem? Well, it was phase one as part of it. Now, as I mentioned before, the organization didn't have necessarily the resources to internally take the cameras and integrate that into a complete system. So in this case, from a phase one perspective, it was 3 cameras, 1 nadir and 2 oblique. The 1 nadir was a 90 millimeter lens, the 2 oblique were 50 millimeter lens, and then that was integrated or connected to the IX controller. And of course, you can synchronize up to 6 cameras with this particular computer. In this case, it was 3. But we needed the help. Phase one couldn't do that by ourselves. At the time, we used SoftNav. SoftNav took the phase one cameras and integrated it with the flight management system, a stabilized mount, a positional system, and then the post-processing software for counting. And this is the cool part. I mean, this is the part that, I mean, to me, just brings it all back home. You have this complete system, phase one and SoftNav, that's built this system to capture imagery in caribou. But now, you know, what does that look like in action? Well, now those images can be run through analytics. You can see some of the variable options in the lower left-hand corner of how to count caribou. So it's looking at RGB colors and how they're grouped together that would make up a caribou. But if you remember, if you recall, when we first started this a few slides back, it's not just the caribou as a whole, which is important, it's how many babies are there. And obviously with 1 inch, I should show you that, with 1 inch to 1 3/4 inch GSD, you can pretty easily identify a calf versus a mom or a dad. So you have that ability then to better estimate and better count how many babies or calves are in these herds. And this correlates directly to harvesting. Okay, so what made it possible? Well, you had a CMOS sensor with the phase one camera that had a dynamic range in ISO of 50 to 6400. This allowed for capturing quality imagery in low light conditions, which is common in Alaska. This increased your collection time during the day and extended the season to get more captured. With the 300 megapixel cameras, you had 1 to 1 3/4 or 1.5 inch plus GSD. This allowed you to easily identify and count accurately. It allowed you to capture many herds in one pass. And because it was less flying time over the herds, it was less disturbing to them. And remember when they had to stop and reload for film? Well, with the IX controller unlimited storage device with multiple SSD drives, they're able to continue their mission without having to stop. And last but not least is the geospatial information on the images. This makes them easy to stitch together, and there's no guesswork of what we've missed. If you've noticed on some of those slides, excuse me for a minute. If you notice on some of these slides, you'll see that the caribou are always associated or some patch of snow. In the summer, the insects can be unbearable, so to help protect themselves, they find the colder areas that minimizes that irritation. If you'd like to learn more about the caribou in Alaska, the June 2018 newsletter of Alaska Fish and Game talks about this particular story. In addition, you can go to their website, learn more about the caribou management and research. Then I have another zoomed in image on the far right there. But we can't leave out any other animals or birds or etc. Obviously, with the high resolution cameras based on the focal length, getting better than 1 inch GSD can be used for other monitoring of other mammals and or birds, etc. All right, we're almost there. We've gotten 2 out of 3 down. The last one is unique in its own right because before we talked about a single camera with multiple sensors, then we covered a 3-camera array, Now we're talking about two cameras that have different outputs from each camera, and that's the 4-band system. So the problem that's being addressed with this particular issue is that, neglected pools and standing waters are breeding grounds for mosquitoes. So the need to detect those and identify those is really important from a health perspective. From a business case perspective, there are some states in the US that have funds to help remediate mosquito breeding. California is one of them. They've had a program in place for over 100 years. But they're not alone. Texas, Florida, and other states, and I'm sure other parts around the world have programs similar. So finding these pools or these areas and then mitigating them are very important. But when you're using just a camera, an RGB camera by itself, there's challenges to correctly identifying untreated pools. I mean, that pool has to get really bad to be able to identify that in an image. So you get a lot of false positives as a result of that. One agency shared that it cost them $50 just to do one inspection. So if you can imagine the amount of pools out there to do an inspection, it's not cost effective for feet on the ground. It makes sense to do it from an aerial perspective. Now the company, the technology integrator that's done this, they've done this for quite a while. From 2007, I believe, was when they started with a lower resolution camera. But they became an integrator in 2014 with our RGB camera, an 80 megapixel, which basically at 1 mile or 5,000 AGL, they were able to get 4.5-inch resolution. They still had those similar challenges. So in 2017, they integrated the 4-band camera system. So now you have NAR and RGB. Now because of the resolution, they can get 3-inch resolution at 5,000 feet. Now, everyone has a choice when you go upgrade to a higher resolution. Do I fly higher and get the same GSD and more coverage, or do I fly at the same height and get improved GSD? That comes down to your application. In this case, the technology integrator aerial services chose that the better resolution was improved over the area coverage. Now, if you think about today, if someone has an 80 megapixel camera today and to consider a 150 megapixel option, you could double your area coverage at 4.5-inch GSD. What is this 4-band system? So really, it's made up of a couple of cameras, as I said before, RGB and an NAR camera. It has a controller with it and IX capture. And you'll see on the far right the type of deliverables that come from this setup. RGB image, NAR image, a combined infrared image, and or color infrared, and we'll cover that as well, and NDVI. It's important too that we don't stop at just creating the image. We have a workflow as well that doesn't have to bottleneck in a third-party software. So we can take the imagery, we feed it through our own software to create these outputs. And just as a snapshot of the screen that is used for that in IX Capture, I just wanted to show that because it's very simple and easy to use. So typically, a 4-band solution is associated to vegetation health, to determine if it needs more water, if it's stressed, what have you. The application for this is looking at pools or breeding grounds for mosquitoes. Now, when you look at this image, you'll see that it is a clean pool. There's no sign of chlorophyll. When I go to the next image, you'll see that that same pool in the 4-band or the CIR, two things. It has a pool cover, and that pool cover has a chlorophyll signature on it. Just so that you can see them side by side. This is with the camera RGB by itself as a result, but then looking through a 4-band image, then identifying that this is a pool that needs mitigation. Another slide, another set of images. There's 3 pools here, which again, from the RGB, from the naked eye, these are clean pools, no sign of chlorophyll. But after a closer look, there's 2 pools that need addressing. One of them has a pool cover and has a chlorophyll signature, and the other one needs to be remedied as well. So you can imagine the increase in accuracy of identifying pools with the 4-band system. Now we talked a little bit about or mentioned NDVI. This even comes into play here. So again, associated to vegetation, the normalized difference vegetation index basically takes all the bands and squeezes it into a -1 to a +1. And where this comes advantage is in a situation I'm about to show you here. So if you focus on the pool in the lower left-hand corner, it's a little darker blue. You see part of it shadowed, but nothing's really coming in from a chlorophyll signature standpoint. But you run it through the NDVI analysis, where that shadow was, you actually see there's chlorophyll that are building there, and this is from the NDVI. I will put those side by side for you to better look. So even from a 4-band to an NDVI analysis, there's more information that can be ascertained. So the conclusions of this particular now is the 4-band increased the pool chlorophyll detection. It was able to pierce through the shadow with the NDVI and still identify where there might be areas to be addressed. They increased their resolution by 20% with 100 megapixel, and now they had new ways to show the chlorophyll. So you'll see a common theme within these 3 areas: high resolution, amazing GSD, dynamic range, all being really common with all 3 of these applications in how phase 1 was a good fit for their solution. Let's talk about our solutions here for a minute. I don't want to leave out the UAVs. I know we've had other webinars on UAVs, but we do have cameras specific for the UAVs in different platforms and different applications. They're lighter. They have specific features that are meant for the inspections and so forth. With our new 150 megapixel camera release, which we're very excited about, we've had a big push on our systems with fully integrated with GNSS, the stabilized mount, and flight management software. So another option there for you with a single camera RGB or a 4-band. I had to plug this next week on Wednesday. If your schedule permits, come by and visit us at the Rocky Mountain Airport at our office. We will be doing an open day for our aerial system showing the 150 megapixel and the 190 as well. It'll be very exciting. Hope that you can come. If you want some more information, please email me after this presentation. I'll set up arrange for you to be there. There's just a couple of images showing just the amazing 4-band quality that we get from our imagery. And then this year highlighting the speed of capture. You'll see, I think this is on other literature as well. Okay, let me see if I can, if we have any other things to cover. You'll see my contact information there. It looks like you're all still trying to come up with some questions. I don't have any to discuss right now. So it looks like we're in good shape. Yep, that's it. This has been an amazing webinar for me to be able to present. I really appreciate that opportunity to do that. I hope everybody here has learned something from this presentation, and a lot of times it stirs up more questions afterwards. So you have my contact information below. Please feel free to contact me at your convenience, and we'll be glad to get those answers for you. That concludes now our presentation.